Today I'm using a new platform to stream my videos, so I hope everything works smooth. And if it doesn't go well, anyway, we can try it any other day. But what I'm trying is to stream to many different places at the same time. So hopefully you can watch me now from Facebook, from YouTube, and even from Twitter. This one I'm not pretty sure because I'm using Periscope and I'm not really sure how it works. So hopefully everything will go smooth. As I mentioned, today I want to talk about inline and reified types, which are a couple of topics that I have been asked to talk about several times. And hopefully with the examples that I'm showing today, it will be everything much more clear than before. So if you give me a second, I'm going to share my screen. 1 second. And we can start. It's here. Okay. So hopefully you are now watching my screen, and what I'm doing today is to explain inline and reified with a very simple examples that can help you understand how they work. First, I want to start with inline, which is a reserved word that will help you simplify your code and make your code much more efficient, because it will save you from creating different objects that you probably don't need. This inline word, what it does is to substitute the call to a function with the content of that function. And this opens up several features that we'll talk about today. But to understand how it works, it's easier if we create a very simple example. For instance, imagine that I'm doing here a toast make test with context this, the text hello world, and toast then toast length short, for instance, dot show. We are going to create a function that simplifies this task. I'm creating an extension function. I talk about them in a previous video, so check out my YouTube channel and you can find them there. But today I'll go straight to the point. I will creating an extension function over context that will create a toast with a message of type string. And I'm copying this. Here and sorry, we don't need that part, and import here. So now every context have a new function that is called toast, where I can do hello world here. Okay, if we check what's the bytecode that this is creating, we have a very powerful tool called show Kotlin bytecode, and if we open it here, what we see here is the bytecode that this code is generating. Obviously, probably most of us are not able to understand this bytecode, but we can decompile it and we'll have like a Java version of the Kotlin code that we are writing. If we go here to the main activity, in onCreate, we'll see that we are calling main activity KT. This is because the Kotlin needs to create like a fake class, a made-up class to introduce the functions that we are not putting inside a class. So this one is called as the name of the file plus KT, main activity KT dot toast. So we see here that this is a normal call to a function that then if we go to the code, we'll see that it's doing the toast make test and all the code we added to the function. This is pretty normal, apart from the extra lines of code that Kotlin is adding to work more smoothly. So if we get back here to our code, let's see what happens if we add the inline reset word we prepend it here. If we now check the bytecode again and see where the call to that function was, it was here. We now see here that instead of calling the toast function, we are just seeing the code that was inside the function, all the toast, make text, etc. So this is what I mentioned, the inline function. What it does is to substitute the call to the function with the content of the function. In general, this doesn't have much sense. In this case, we are doing something that is not very necessary because we are not doing anything more efficient. But this will open up a couple of features that I want to show you today. The first one is that we can save creating some videos, some objects by doing this, and I'm showing you an example right now. Imagine, for instance, that we want to create a function like this, also a top level function that is not attached to any functions, to any class, so that we can use it everywhere in our project. Imagine that we want to do something like this, do on debug, and set here a lambda that will only be executed in the case that we are on a debug compilation. If we are compiling through release, we don't want to execute this code. This can be pretty normal. For instance, if you only want to crash if you reach to an invalid state in the case that only in the case that you are in debug, because you don't want to crash the release version or something like that, or you want to do some extra checks on debug that you don't want on release. So we could do something like this. Pass here a lambda that doesn't receive anything and also doesn't return anything. And in the case that we are on a debug compilation, build config.debug, then we'll execute the body. In any other case, we won't do it. And now imagine that here we have reached to an illegal state, a situation that shouldn't be happening, that we only want to crash if we are on release, not on, sorry, only on debug, not on release. We could do something like this, do on debug, and throw illegal state exception. Good, so this code inside the lambda will only crash if we are on a debug compilation. If we now check this code, we decompile, we'll see here that this is creating a new object that implements a function that represents this lambda. This is not a problem if we are just creating a single object, but imagine that we have this function inside a loop and this loop is running like 10,000 times. We would be creating 10,000 objects for this function. What can we do to simplify this? If we can substitute the call to the function by exactly the content of that function, we can avoid creating this object and we will save the object creation, so our code will be more memory efficient. So let's do this. If we get back to our main activity and I write inline here, let's see our code again. Let's check again the onCreate, and what we have here now, instead of the call of to that function, to the do on debug function, this has been substituted by this code, the if that checks that we are on a debug compilation, and then it is throwing the illegal state exception in the case that we are on debug. If we are not on debug, this if will be false and will continue executing the rest of the lines. So as you can see, we have now efficiently removed the need to create an object only to represent that lambda. So having this in mind, we can think that when we are using functions or extension functions that have a lambda or that use a lambda as an argument, we can think about it and decide whether it's interesting to do that function inline so that we don't have to create that object every time we call to this function. It depends a little on the complexity of the function, because think that this function is going to be substitute in every place where the function is called. So our code could grow dramatically if it's a function that we use a lot and its function is very long. But in general, you don't have to worry much about it, because we will be using it in very simple situations. But inline not only works for this, as a side effect, it also allows using another feature of the language, which is the reified types. The reified types are a way to convert a type to an object, at least in a logical sense, so that we can use it inside a function. Let's play this with an example. Imagine that what we want to do now is to start a new activity, start activity with a new intent this detail activity dot class Java. So imagine that instead of doing this, we want to build a generic function that will receive this as the generic type of the function, and then we can create the intent inside and start the activity instead of having to do this every time we want to navigate to another function. So we are creating this function that would be something like this. Inline, without the inline. Function start activity, and we have here a type that extends activity. This function will be used by any context, because if you see here, we are using the context to create the intent. So we can create this as a extension function for context. And what we want to do from the inside of the function is this. So we would have start activity, detail activity, and that would be it. We move this inside, and here, instead of using detail activity, of course, we would use the generic type that we are specifying when we are calling to the function. What's the problem? That we cannot use the generic type inside a function. This is because of type erasure, because when Java compiles to bytecode, the bytecode loses the information of the generics. So we cannot use them effectively inside the function. What has created Kotlin to overcome this? A concept that is what I mentioned, the reified types. With a reified type, we can use that type inside the function. So the only thing we need to do is to write reified here, and now this is no longer crashing. The only thing that we need to do is that we are forced to add the inline modifier to the function. And why is this? If you think about it, we mentioned at the beginning that when we use inline, what we do is to substitute the call to the function by the content of the function. And we also said that the problem with generic types is that we lose the information of the generics when we get into a function. So the clue is here. If we don't call to a function, we are not losing the information of the generic, so we can effectively use it from the outside. But Kotlin wraps everything up by using Reified and Inline, so that we have the impression that we are calling a function. But in the end, this is everything being unwrapped when compiled, and we will only see the code of the function instead of the call. If we now go to Kotlin bytecode again and check by using the compile, what we are seeing here is that instead of using the call to start activity, the new extension function that we created, this is just using the content of the function, the regular start activity that is creating the intent, and as we are using the generic outside the function, we are just calling detailActivity.class. We can use it here without any issues. We wouldn't be able to do this if it's inside a function, but when we unwrap it, it is possible, and it allows us to simplify the code when we need to use the class of a generic, the type of a generic. Another very typical example of this could be this one. Let me go to test here. Imagine that we are in a situation where we are getting a JSON, which is of type string, and we want to convert it to one of our classes, for instance, to a person. This JSON represents a person, and we want to convert it using JSON. So here we could create the JSON object and use the function from JSON that requires the string and also the type of the class. This is again because even if we do this function generic, which in fact it is, if we go to the code, we see that this function is generic, we cannot use that generic type inside of the function. So the only way is to set the type as an argument to the function, and then we can use it inside. But with Kotlin and Reified types, we can wrap this into a function so that we don't need to do it ourselves. How can we do this? We can come here and do fun from JSON. I'm calling it the same way as this function, from JSON, and this is receiving the same JSON of type string, but we are not passing the type as we were doing in the original one. We are just doing t. Here we are generifying the function, and this will return an object of type t. As we are going to apply this to the JSON object, the JSON type, we can use the regular from JSON inside this function. So we make this an extension function of JSON, and then here we can equals this. Sorry, to from JSON, receiving the JSON and passing the class Java. Again, we have the same problem as we had before. We cannot use t as a Reified type parameter. This means the same that we told before. We cannot use a generic type inside a function because we lose that information when we get into the function. So what we can do here is to make this function Reified and also make this function inline. And with this, we can avoid specifying the type if the compiler is already detecting the type. So we could do something like this. This function is returning a person because it's detecting that this function returns a person. So this other function, the front JSON, automatically is generified to this type, to the person type. We could do something like this, but as you will see, as the compiler already knows it, it will suggest to remove it. It's the same, and we can prevent it because this is already all inferred from the context of this line. And these are the examples that I wanted to show today. And that's all I had for today. I hope that with this information it helps you to understand better how inline functions work, how Reified type works, and why they need to work together in the cases that we are using Reified types. I really hope that with all this information you have a better idea on when and where you can use it. And as I mentioned, these live events are done every week. So if you have any ideas or any suggestions of something that we can talk about, please let me know in the comments of any of the platforms where you are watching it, and I'll be happy to use those ideas for the future videos. So thanks again for watching here, and see you. Bye.